All right, the purpose here is to get this hexadecimal value, convert it into binary 32-bit word length machine code, and then we're going to take this and convert it into an assembly language instruction. So real quick, we take every value and convert it into its binary 4-bit binary representation. This will give us 32 bits is what we're looking for. First, it's going to be divided into 6 bits, 5 bits, 5 bits, and then the rest, it's really determined on what kind of opcode you're using. So that's the first thing you check. So because there's three types of instruction formats. So when we check the opcode, the first 6 bits, we get that the value is 13. Hexadecimal is this value, and then in the reference sheet we find out that that represents and immediate. So now we know we're using an immediate format, also called I format. So basically from there we divide our bits into this format, the I format. That way we can assemble our instruction and see what it's trying to ask us to do. So again, opcode is and I1, and then we have two registers, RS and RT, and RS is going to store a value of 4 from the 5 bits, and then RT from the 5 bits here is going to store a value of 10. Immediate is going to store a constant, which through the bit is 3, so that's going to be our constant value there. So when we rewrite the instruction, we're going to have and immediate, which is going to have register T2. So 10 represents register T2, which is a temporary register, and 4 is representative of register A0, which is argument register. And then again, the constant is hexadecimal 3, is also the bit 3. Another thing I meant to mention was that this is divided up. Here the operations call is considered an opcode field, and then the rest is the operand field. All right, going back to the remaining, once we have this instruction, we kind of break down what it means. Basically, what this is saying is that in register T2, we're going to store the bitwise AND, which means every bit in these are going to be compared, and the AND of that is going to be taken, that's going to be stored in T2. The purpose of this is to create a mask, and that way you're only getting the bits that you want from this register. Here are two examples where, let's say A0 was 5, which is 0101. You AND that with a 3 and you get 01, which is the same as there. Same here, let's say A0 holds 7. You AND that with again the 3 and you keep the 2 that you wanted. So that's the purpose of that, and that's what we get from there. Continue on to the next portion. It's very similar, same steps. The only difference is we are going to have a different instruction. Again, the opcode, we find that it's 4, which is a BEQ, which is a branch. So this is going to have an offset, kind of similar to the immediate. It's still an I format, but the offset is not a constant. It's going to be an address. So it's going to address us where to go. So we got 4 BEQ, RT is 9, which is register T1, RS is 0, which can be 0, or I believe it can also be register 0, which holds all zeros, which is equivalent. So basically what this is saying is branch if equal. So if register T1 is equal to 0, we're going to branch to the address, which is this address right here. Again, this was obtained the same exact way. First, we broke down into 32-bit word length in binary. We found the opcode. Knowing that opcode showed us that was going to be a I format using an offset. And then we had two registers, and we broke it down to the assembly instruction. So that was pretty much straightforward of that. Thank you for your time, and I hope I provided equivalent information that you were looking for.